Hi friends, welcome to the next part of analog electronics. So we are solving problems based on bipolar junction transistor. Of course, we are learning the concept through problems. In the last session, I had given one question for homework. How many of you did this? If you found the answer for this question, just do let me know in the comment section. Drop your answer in the comment section. I'll be waiting for your answer. What can be the expected answer for this question? Anyone? The value of collector resistance is dash, right? That is the question. How many of you solved this question? If you solved, just drop your answer in the comment section. Chalo. Okay, no issue. Let me try to solve. The question is, what is the value of collector resistance, right? Sir, how should I solve this? The value of VCC is given. What are the data is given? Let us substitute all the given data. So let me take that circuit one more time here. So what they told is from everything is given. So if you observe, VCC value is given. They are calling it as RCC. Then here they have attached one more feedback resistor. After that, the circuit is continuous. This is bipolar junction transistor. Then this portion is directly bypassed with the ground. And they are attaching these two. Fine. Everything is finished now. This is going to be collector resistance RC, and here how to connect this? They have given this voltage is what? Plus VCC. Chitra Devi 435 kilo ohm, 4.35 kilo ohm. Let's see. Good. At least few of you did this. See what they told? Plus VCC. So you know how to connect this, right? So this is minus plus. The value of VCC is given as 15 voltage. Next, they have given some other data. Let us try to mark by identifying its positions. VCE equal to 4 voltage. Where is collector to emitter voltage? Collector means this is collector junction. So plus minus collector to emitter voltage equal to 4 means this is collector to emitter voltage. After that, they told collector current is 2.5 milliampere. Sir, where is collector terminal? I know this is collector, this is base, this one should be emitter. So collector means this is the current that is entering into the collector. Yes or no? So that current they have given us 2.5 milliampere. Okay, sir. Fine. Next, any other data? Yes. The value of base to emitter voltage also given as 0.7 voltage. Any other data? Yes. So value of beta also given as 100. Later we will use this beta. As of now it is not required. Sir, if the collector current is directly going here, directly entering into collector terminal, then what is the current that is flowing through resistor RC? Anyone? Can you tell me? Yes, sir. Let us see what will happen. You know, the current carried by the base terminal is called base current. I can call it as IB. So this current will be going like this. Yes, sir. Same current will be. Same current has to enter here. Now, if you are applying KCL at this junction, according to Kirchhoff current law, current leaving, algebraic sum of leaving current at any node must be equal to algebraic sum of incoming current. Okay. So the incoming current, see if you observe from the top layer, there is one current is going, that current is unknown. After reaching this node, one current is entering into collector. So that current we are calling it as IC. One more current is leaving to base terminal. That current we are calling it as IB. Now if we apply KCL, then I will become the algebraic sum of base current and the collector current. Yes, sir. So we got the current that is flowing through the collector resistance. And one more thing what we know, the another thing what we know here is the value of current that is flowing through the emitter. See, basically this is emitter terminal and the current that is flowing through the emitter is called emitter current IE. Okay, sir. Now, how will you write the emitter current? We all know emitter current is, if you apply KCL there also, that is algebraic sum of base current plus collector current only. So from this what we found, this current and this current both are same. So current through the collector is simply known as emitter current only. Yes sir, that's very simple. Now how should I find out the value of RC? If you want to know the value of collector resistance RC, then you must see. Let me take collector resistance in this manner. How will you identify the value of RC value? According to Ohm's law, if I know, see, current through the emitter, sorry, current through the collector is, sorry, RC is IE. So current entering point plus leaving point is minus. Let me call voltage drop is V. So according to Ohm's law, if you want to know the value of RC, R is equal to V divided by IE. If you know these two data, then you can easily identify the value of RC. So I must know the value of voltage drop across this resistor and current through the resistor. Can you identify the value of voltage drop across the resistor? Is it possible? I hope it is possible. How, sir? Let's see. Let's try to trace out these things one by one. Since the emitter current is going in the downward direction, so current entering point plus leaving point is minus, and I am simply calling the voltage drop across the emitter is V. Now, can you please apply KVL from collector to emitter in the downward direction like this, in this direction directly from top to bottom? What will you figure it out? If you apply KVL in this manner, then you can figure out this one. See, there is one battery, and then we have our RC resistor, then transistor will be replaced through collector to emitter. We know how to replace it, that voltage also given. Then in emitter there is no any resistor, they have directly bypassed it. And here I am assuming that the voltage is V, current entering point plus leaving point is minus, and this is connected with the ground. We all know this voltage is already given as 15 voltage. So now if we apply KVL for this Kirchhoff voltage law, from the top to bottom you will be getting minus 15 voltage plus voltage drop across the RC, I am calling it as V, then plus VCE is 4 voltage equal to 0. See there, minus 15 plus 4 will give you minus 11, or I can say V is equal to 11 voltage. So the first conclusion is we found the voltage drop across the collector resistor. So the value of voltage drop V is 11 voltage, first conclusion. Next we must know the emitter current, that is current flow through the collector resistor. How should I figure it out, sir? So for that, let me take, we all know emitter current IE can be written as, it is the sum of base current plus collector current IC. How should I write it further? See, what is the given data here? The given data is collector current is known. If you know the value of collector current, then it is very easy to identify the value of base current, emitter current, everything. How, sir? See, collector current is given, beta also given. What I am going to do now? See, what I am going to do now is collector current is given, right? So I am trying to write the I base current in terms of collector current, such that in one step we can figure out the answer. How will you write down this relation, sir? Sir, we all know collector current IC equal to beta times of base current. From this, I can write base current IB equal to collector current IC by beta. Yes or no? So we can substitute this relation here. So IB will be replaced by collector current IC by beta plus collector current IC. Just to simply apply your KCL KVL, you will figure out the answer. So from this I can say emitter current IE can be written as, if you take collector current outside, it can be written as 1 by beta plus 1 into collector current IC. So let us proceed further. So from this, if you take LCM, cross product, then it will become 1 plus beta by beta into collector current IC. What is the value of beta here? 100, sir. What is the value of collector current? 2.5 milliampere. So from this, we can write emitter current IE is equal to 1 plus beta means 101 divided by beta means 100 into 2.5 milliampere means 10 power minus 3. So what we have to do? 101 divided by 100, it will give you 1.01 into, if you multiply it by 2.5, we will be getting here, it will become what? 2.525 into 10 power minus 3. That is the value of emitter current. So we found the value of emitter current also. Already we found the voltage drop across the collector resistor, that is 11 voltage. Now it's time to explore the value of RC. So the value of RC equal to voltage drop across the RC divided by current flow 2.525 into 10 power minus 3. Now if you pass this 10 power minus 3 to the numerator, it will become plus 10 power 3. So 11 upon 2.525 into 10 power 3. So from this we can further proceed. So if we take uh, 11 divided by, so I am getting 4.356. 10 power 3 means kilo ohm, right? So that is the value of collector resistance. Successfully we found the value of collector resistance. Suppose in the same question, if you are requested to calculate the value of base resistance RB, how will you calculate? Do you know they have given one more resistor also? Have you been observed or not? See there. This is called base resistance. How will you calculate the base resistance? To know the base resistance, current flow through the circuit, we can call it as base current IB. So current entering point plus leaving point is minus. So to know the value of base resistance, we must know the voltage drop across this resistor. I'm calling it as VB. So I'm just calling it as VB. Divided by current flow through the circuit is IB. IB we can easily figure it out. How, sir? IB equal to IC by beta. See, this is the relation. We know the value of IC, we also know the value of beta. So we can easily find the value of IB. How will you find out the value of VB then? To know the value of VB, now you must apply KVL for this loop, second loop. Shall we write the equation? Yes, let us continue now. To know the value of RB, right, just now we saw, to know the value of RB, we must know the voltage drop across the RB divided by current flow through the RB. We must know to these parameters, these two parameters, right? So the value of VB and IB, how do I figure it out? If I will apply KVL through the base, again, we should start from battery, then we are facing collector resistor. Then after reaching this junction, we are changing the route. Now we are traveling through base. So again, while crossing the transistor, we should not avoid the diode, base to emitter diode. We know how to represent its polarity, plus minus 0.7 voltage. In emitter, there is no any resistor, it is directly bypassed to ground. So this is called RB, and the current flow through this RB, we are calling it as IB, and the current that is coming from this branch, we are calling it as IE. But we know the voltage drop across RC, that is 11 voltage, we already found it. And this is minus, this is plus, here we are having 15 voltage, this is connected with the ground, and here I am calling it as VB. How will you figure it out now? Just apply KVL one more time. If you apply KVL, again start from minus 15, then the voltage drop across the VC, that is a resistor RC, is 11 voltage, then again plus base voltage, that is not known. See why I am putting plus here? Current entering point plus, leaving point is minus. So here I am going with the entering polarities. That's why, see, first one is minus, second one is plus, third one is plus, next one also should be plus. 0.7 equal to 0. Now, minus 15 plus 11 will be giving us what? Minus 4. Minus 4 plus 0.7 will give you minus 3.3. So I can say the voltage minus 3.3 means while passing it to the right side, it will become plus 3.3 voltage. So we found the voltage across the resistor, that is base voltage, that is 3.3 voltage. We can write this voltage is 3.3 voltage. Now how will you figure out the value of RB, sir? So the value of RB equal to, let us continue, this is 3.3 voltage divided by base current can be replaced by collector current IC by beta. Denominator of denominator will be in numerator. So further we can write 3.3 into the value of beta is going to be 100 upon various the collector current they have given 2.5 milliampere. Milli means 10 power minus 3. Now what can be your answer? Solve this and try to drop your answer. So if you figure out the answer for this, just continue to bring down the answer. So I am passing this 10 power minus 3 to the numerator. It will become 10 power plus 3. 3.3 into 100. That will become 330. So 330 divided by 2.5. If you put, it will become 132. So 132. 10 power minus 3 will become 10 power plus 3. That will be kilo ohm. I always told you that the value of base resistance is far greater than the value of collector resistance. You know, the reason is, see there, this collector resistance value is only 4 kilo ohm, whereas the base resistance is in 130 kilo ohm. It is 100 times, almost approximately 100 times greater than this value, right? Yes, sir. So actually, the reason why the value of base resistance is very high, in order to keep very less value of base current, base current is simply used to control our transistor. Okay, fine, sir. I hope you all understood, right? Okay, done. See, this is not actually 100 times greater than this value. That is wrong. So here we are having only some 25 times, right? Near 25 to 30. Fine, sir. Anyway, but the value of base resistance is far greater than the value of collector resistance. Fine, sir. Next, can you please tell me what is the region of operation? Whether your transistor is it operated in active region or saturation region? Can you figure it out? Sir, it is very easy. Why, sir? In the question itself, how? Operating point is already given in the question. You know, operating point is the superstar here. With the help of operating point only, we are identifying the region of operation. See, the value of operating point is collector to emitter voltage, that is given as 4 voltage, and the value of collector current is given as 2.5 milliampere. It is already given. When the value of collector to emitter voltage is greater than the value of 0.2 voltage, that is VCE SAT, then your transistor must be operated in the active region. And I also told that the value of VC must be less than the value of VCC. That condition will be always valid, because see, we are bringing this VCE after subtracting the voltage RC from VCC. Out of this total voltage, some voltage will always get dropped here. Remaining only we will be receiving here. So this VCE is always less than the value of VCC. We don't need to be bothered about it here. Okay, so that condition also valid here. Already VCC is given as 15, whereas VC is only 4 voltage. So that condition also valid. The transistor is successfully operated in the linear region or active region. I hope every one of you got the conclusion for this question. Shall we go to the next one? Chalo. Let me bring the next question. Actually, the next given question is, let me try to draw the circuit first. There is one resistor. Yes, transistor questions are always very easy. Of course, entire electrical engineering is easy only. It depends on the way how you are understanding the subject. It doesn't matter how many transistors they are giving. It doesn't matter whether they are connected in parallel, series. Only thing is how you are looking into the circuit. Just apply KCL, KVL, fundamental basics. You can get the answer. So this is the given circuit. Fine. Now the data is, they told this is 10 voltage and this resistor is 2 kilo ohm. This resistor is 6.5 kilo ohm, and this resistor is 1.85 kilo ohm. 1.85 kilo ohm. This is 1.65 kilo ohm. Now base connection is required, right? Otherwise transistor will not operate. And this resistance, they told, this is 1 kilo ohm. Now what is the equation, sir? The transistor shown in the figure having very high value of beta. Some clue they have given. Beta value is very high. First they told. Okay, sir, beta value is very high. Next, base to emitter voltage they have given VBE equal to 0.65. This time they have given 0.65 voltage. Now the question is, the current I flowing through the 2 kilo ohm resistance will be dash. What is the value of current I here? The current that is entering into the 2 kilo ohm resistor is dash. Okay, you can take your time. I am giving some 2 to 3 minutes. You can try your best. After that, I will be solving this question. You guys just apply your basic sense how to bring the answer for this question. Just apply your common sense. Don't think, sir, we are learning new BJT நீங்க இப்பதான் introduce பண்றீங்க, suddenly you are asking us to solve. I told it is completely related with the fundamental basics of circuit theory. If something which are related to concept, I will be dealing with that. I will be telling that we need these concepts to do this. So these things can be done just with the help of normal circuit theory. Are you guys still thinking? Try. In offline class, suppose either 5 o'clock offline lab, if we conduct the class, do you know what will happen? If I will give this 2 to 3 minutes, student will sleep happily. Aram say we will sleep for 3 minutes. Anyway, he will be going to solve the question on the board. We will sleep for few minutes. They will rotate their head like soldiers. Then we should back up. Hmm? Now the problem is here I don't know how many of you are sleeping, how many of you are watching. Literally after suppose last day night if you didn't slept well, automatically what will happen? It doesn't matter whether the classes is going too much interestingly or something is going beyond your expectation. You will sleep haram say. No sir, I just wanted to sleep. Huh? Chalo, let me try to solve this question. See, basically in this question, what they are asking us is they are just asking the value of current flow through these 2 kilo ohm resistor. They have given some key. What is this? Beta is very large. Why they have mentioned this point? We all know, yes sir, beta is very large. Of course, we all know that. Yes sir, we know beta is very large. So whenever in the question they are identifying this point, it means what, sir? The value of collector current basically approximately will be equal to emitter current. Do you remember? I have been told this many times. Yes. This statement will become valid when there will be no sufficient information to calculate the level of base current, but they are telling that the value of beta is very large. Yes, that is this question only. So just do remember. So hereafter, by default, in any question, if they are telling that the value of beta is very, very large, then approximately collector current and emitter current will become same. Now, if you observe, there are two transistors. This is transistor 1, transistor 2. When collector to emitter current both are same in this, only we have transistor, two transistor, and they haven't told that we are having two different transistor. They simply said there are some transistor. It means they are identical to each other. Whatever the property that you are observing in the first transistor, that will be similar to the second one. Fine, sir. Next thing, when collector current and emitter current are equal, it means what? This is the collector terminal. Observe. For the transistor 1, this is the collector terminal. So this is collector current, this is emitter current. When both are same, so whatever the current that we are carrying here, so they told that collector current equal to I. They are calling that current is I. Then emitter current also will become approximately equal to I only, because they said the value of beta is very, very large. Now if you observe, this emitter current will going to be a collector current for the next transistor. Don't sleep. I'm just telling, see, first transistor is over. Now this emitter current is entering into the another transistor. In the another transistor, the entering current is called collector current for this transistor. So this emitter current and this collector current both are same only. Here I am calling emitter. Why? Because for the first transistor, this terminal is emitter terminal. For the second transistor, I am calling it as collector because this terminal is collector terminal for that. Anyway, both are same only. Again, according to the given data, collector current and emitter current both are same. So this emitter current and that collector current, this one, both are going to be same. Same I will be flowing here also. So what is the conclusion? Current flowing through this 2 kilo ohm resistor and current flowing through this 1 kilo ohm resistor both are same only. So now you are requested to calculate the current flow through the 2 kilo ohm resistor. But what we concluded here is current flow through the 1 kilo ohm resistor and 2 kilo ohm resistor both are same. So if you identify the current flow through this 1 kilo ohm resistor, then you can easily say the answer for this 2 kilo ohm resistor also. So current entering point plus leaving point is minus, whereas the voltage drop, I am calling it as VE simply, the voltage drop across the 1 kilo ohm resistor. Fine, sir. Now how should I proceed further? Remember one more thing. When beta is large, then we are saying that the value of collector current is approximately equal to emitter current. From this data, we know basically emitter current can be written as it is the algebraic sum of base current plus collector current only. This is the actual relation. So here, if I am writing that the value of emitter current and collector current are approximately equal to each other, it is clearly indicating that the value of base current, we are equating this base current is approximately to what? Can you please tell me the answer? When these two currents are approximately equal to each other, it means approximately we are just equating the base current to 0 ampere. We are just ignoring this effect. Guys, you have to remember, immediately your mind will say, அது எப்படி சார் ஜீரோ ஆக்க முடியும்? நீங்க பேஸ் கரண்ட்டை ஜீரோ ஆக்குனா டிரான்சிஸ்டர் என்ன ஆயிடும்? ஆஃப் ஆயிடும். Then it will enter into cut off region. Then how will you proceed further? Operation பண்ண முடியாது. Of course, you all are correct. But while solving the problem, they told that the value of beta is very large. In the sense, the value of emitter current and collector current may be in milliampere and this base current may be in nanoampere. If it is nanoampere or in the range of 10 power minus 6, 10 power minus 7, even in microampere also, I have been told you many times. Micro means 10 power minus 6. You have to write 0 point after keeping 5 zeros only you can write the data. Suppose if it is 3 microampere, then 0.00003 ampere. See, this value is approximately equal to 0. I am not telling that exactly equal to 0. So base current never be 0 here. We are approximating to minimize this question in a simplest way to solve this question to understand the actual property behind of this question. So we are just ignoring the effect of this base current because it is not significant in the voltage drops because this value is very less. So the conclusion is whenever they are telling that the value of beta is very large, approximately equal to just to equate the value of collector current with the emitter current, and just write down the value of base current is approximately equal to 0 ampere. That's all. I am reminding one more time, base current is approximately equal to 0 ampere. Okay, for this question. அப்ப இந்த மாதிரி data கொடுக்கும்போது you can just consider it is equal to 0. Okay, when the base current equal to 0, you can write in both transistor it will be 0. When you will write this kind of things, these cases could be possible when the value of beta is very, very large. Okay, I hope you people understand what I'm trying to conclude it. Fine, sir. Now, chalo, let us see. If the base current is 0, then see there. If you observe the 10 voltage supply voltage, this 10 voltage positive plate is directly connected at this node. Of course, with this node also. Here we are having plus 10 voltage. And its negative plate is connected with the ground. So here we are having 0 voltage. Yes or no? Yes, sir. Now I can say here I am having 10 voltage and here I am having 0 voltage. I just wanted to know the voltage drop across this 1.6 kilo ohm resistor. Why are you asking about it, sir? I will come to know that because I will tell you why I am figuring out it. I just wanted to know the voltage drop across this 1 kilo ohm resistor. Then only I can figure out the value of current I. Yes, sir, that is possible. Now, see, the voltage drop across the transistor is given as 0.65 voltage. Yes, if we found the voltage drop across this 1.6 kilo ohm resistor, then if we apply KVL here, it is very easy to figure out the voltage drop across this 1 kilo ohm resistor. Then we can easily identify the current flow through the circuit. Current I can be easily detected. Shall we start? Yes, sir. Since the base current is 0, current is 0 in the sense we can ignore this branch now. Yes, sir. So whatever the current that is supplied by, current always flow from higher potential point to lower potential point. So this 10 voltage source will be delivering some amount of current, some reasonable amount of current according to the load that we have connected here. Now what will happen? This current will come here after reaching this junction. Observe this. Is there any changes in the value of current flow? No, sir. Why? This base is carrying 0 ampere only. So this current will be simply started flowing through the same branch. Again, it is going here. In this branch also, there will be no any effect in the current flow. Again, that current will be going like this. So what I can say? So because of this elimination of the base current, the 6.5 kilo ohm, 1.85 kilo ohm, 1.6 kilo ohm resistors are become series. So now they are connected in series. They are just acting the way that they are connected in series, because see, just we are ignoring the effect of base current. Because of that, there will be no current flow in the base current. There will be no any current flow in the base. So because of that, these all resistors are connected in series in resultant. Even they are connected in series, can we apply voltage division rule? Of course, sir, voltage division rule will be effectively utilized for series circuit only, because in parallel circuit voltage will be remain same. We can't apply voltage division rule. We should not, right? Fine, sir. Then according to voltage division rule, if you want to know the voltage drop across this 1.65 kilo ohm resistor, let me take the voltage drop across the 1.65 kilo ohm resistor will be equal to total supply voltage into resistance offered by the 1.65 kilo ohm. Kilo ohm means 10 power 3 upon the overall resistor. Overall resistor 6.5 plus 1.85 plus 1.65 into 10 power 3. 10 power 3, 10 power 3 will get cancelled here. Now if we add all these values, 6.5 plus 1.85 plus 1.65, so it will be equal to what? 10. So 10 upon 10, it will get cancelled. Into we have 1.65 only. So this will be equal to 1.65 voltage. So we found that the voltage drop across this 1.65 kilo ohm is resistor is 1.65. Now for a better understanding, I am just drawing that circuit alone. We have a 1.65 kilo ohm resistor and it is connected with a transistor. Now transistor can be replaced by what? Plus minus 0.65 voltage. It is already given, right? Now this terminal here we have emitter 1 kilo ohm resistor, and we are assuming the voltage here is VE. I told current entering point plus leaving point is minus. Yes, that's all. This is ground. Fine, sir. And here now we know this is plus, this is minus, and its voltage is 1.65 voltage. Do you know how I am putting this polarity? How? We know for the last branch, current is coming from what? From top to down. It is coming from up to down. When it is coming from top to bottom, according to the direction of the current, resistors are always considered as a passive element. For the passive element, current entering point plus, leaving point is minus C. Since the current is coming in the downward direction, so current entering point plus, leaving point is minus. Now if you apply KVL for this loop, what you will be getting? Let us start from here. Minus 1.65, yes sir, 1.65, then again plus 0.65, yes, plus 0.65, then again plus voltage drop across the 1 kilo ohm resistor equal to 0. Minus 1.65 plus 0.65 will be equal to minus 1. If you pass that minus 1 to the right side, it will become plus 1 voltage. Finally, successfully we found the voltage drop across the 1 kilo ohm resistor. Now, if you know the voltage drop across the 1 kilo ohm resistor, it is very easy to find out the current I, because according to Ohm's law, I is equal to V by R. Emitter resistor, we can call it as RE, voltage drop is VE. So this is 1 voltage by the value of RE is 1 kilo ohm. Kilo means 10 power 3. From this I can say 1 by 1 will become 1. If you pass the 10 power plus 3 to the numerator, it will become 10 power minus 3, or we can say it will be 1 milliampere. Successfully we figure out the value of current. So current I is equal to 1 milliampere. That's all. Suppose in the same question, if you are requested to identify the voltage drop across the 2 kilo ohm resistor, what will you do? Voltage drop across the 2 kilo ohm resistor. Simply they are asking just to figure out the voltage drop across the 2 kilo ohm resistor. How should I do this, sir? Now we know the current flow through the entire transistor from the top to bottom is 1 milliampere. The current flow through the 2 kilo ohm resistor also same 1 milliampere only. So it is very easy to identify the voltage drop. So V is equal to, according to Ohm's law, it will be I into R. Since the value of current flow through the resistor is 1 milliampere and the value of resistor is 2 kilo ohm. 2 kilo ohm means 2 into 10 power 3. So now 10 power minus 3 and 10 power plus 3 will give you 1. 1 into 2 will give you 2. So the voltage will be 2. So the voltage drop across the collector resistor RC is 2 voltage. That is the topmost layer here. So here we have the 2 voltage. Yes sir. Now, so what they have given, now you know the voltage drop across this transistor, we know that is 65 voltage. Yes. Now I am asking you one more question. If I just wanted to know the, let me remove this unwanted things here. I just wanted to ask few more questions. So I am removing these things. Just to think, you should solve the question in all possible ways. As a teacher, it's my responsibility to figure out the all possible ways for this type of question. For the same question circuits, suppose if you are requested to calculate the voltage drop across the collected to emitted terminal of the transistor, how will you identify? Any one transistor you can take, but how will you do that? What is the clue that is given for that? If you want to know the value of collected to emitter voltage drop, how will you do that? Any clue that they have given here? Just think about it. Sir, how should I figure out the collected to emitter voltage? Let's see. See, this is collected to emitter voltage. I am calling it as VCE1. And this is collected to emitter voltage. Second transistor, I am calling it as VCE2. How you have to think in a proper way. See, we know the voltage drop across this base to emitter, that is 0.65. Again we know second one also. How should I figure it out, sir? We know the voltage drop across this 1 kilo ohm resistor here. What is the voltage that we got? We have 1 voltage here. Yes sir, we have 1 voltage. And we also know the voltage drop across this 2 kilo ohm resistor, that is 2 voltage. Yes sir, that also we know. Now how can I figure it out, sir? See, can you find out the voltage drop across the 6.5 kilo ohm resistor? Yes, by applying voltage division rule. How will you apply? Again, voltage drop across the 6.5 kilo ohm resistor will be equal to 10 voltage into 6.5 kilo divided by, if you add all the resistor, it will become 10k, k 10 10 will cancel, it will become 6.5 voltage only. So I can easily say that the voltage, we know the polarity, how to polarity, current is traveling in the downward direction, current entering point plus leaving point is minus, it will be 6.5. Now in the top we have a 10 voltage. Yes sir. Now can you apply Kirchhoff voltage law in this way? Is there any mistake? Just think about it. What I am doing is, there are so many ways to raise the question in the examination. We are starting from a 10 voltage source, okay? And I am considering only first resistor. Now I am trying to find out the collector to emitter voltage drop of the second transistor. This one. There is some clue, I'm just trying to follow that. See, first we are crossing the first resistor, 6.5 kilo ohm resistor, and the voltage drop across this resistor, what we got is 6.5 voltage only. This port is connected with the ground, we know. After that I am traveling through the first transistor, and we know this transistor can be replaced through the base. I can cross the transistor from base to emitter, through base to emitter. Sir, our transistor is in active region. Why, why I am not crossing collector to base? We are always going from base to emitter. Why are you not thinking about collector? When transistor is in active region, collector junction is in reverse bias. Yes or no? Emitter junction only in forward bias. Don't forget that. So you can't consider that transistor. You should travel only in this way. So they have given that this is 0.65 voltage. They only told. After that, again, we are crossing the second transistor, but the second transistor I am going to cross the collector to emitter terminal. Then at the bottom we have a 1 kilo ohm resistor. Just observe the circuit. And the voltage drop across this 1 kilo ohm resistor is given as 1 voltage. Now, can you apply KVL? The only unknown is this VCE for the second transistor. If you apply KVL for this circuit, let me write. It will become minus 10 voltage plus 6.5 voltage plus 0.65 voltage. See, first this one and then voltage drop across the resistor, then this diode, then collector to emitter voltage. I am calling it as VCE2, then plus 1 voltage equal to 0. What you will be getting? See, if I will add this two, it will become 7.15. Then if I will add one more one, it will become 8.15. 8.15, here will be having minus 10. So this will give you what? 8.15 means, it will become 1.85. Yes or no? The answer is collector to emitter voltage, VCE2. It will become 1.85 voltage. Let me cross check by myself once, because it's better to avoid the mistake. So 8.15 minus 10, if you put, it will become 1.85. So that is correct only. There is no mistakes in our calculation. This is the collector to emitter voltage of the second transistor. Okay, fine sir. Now the next thing is collector to emitter voltage of the first transistor. How can I identify, sir? Think again, apply your mind. See how I am solving these questions. Am I using anything? இதெல்லாம் உங்களுக்கு தெரியவே தெரியாது, இதெல்லாம் நீங்க லைஃப்ல பார்த்திருக்கவே மாட்டீங்க. Only I know these things. Am I telling anything like that? No. Only KVL. We are just playing with the KVL. Yes or no? Take the circuit one more time. Now I am going to apply KVL in this manner, directly from the top to bottom. Collector to emitter, collector to emitter. So if you start again, there is a 10 voltage battery at the top. Then we are crossing the first transistor, collector to emitter. I am calling it as VCE1. Then directly we are crossing the second transistor. I think I left one resistor, right? Sorry. 2 kilo ohm resistor is there at the top, right? Yes, we should consider it. First, we are crossing 2 kilo ohm resistor. Then collector to emitter voltage of the first transistor, collector to emitter voltage of the second transistor, then 1 kilo ohm resistor. Here we know the voltage drop is 1 voltage. Here the voltage drop is 2 voltage. Here The supply voltage is 10 voltage, and the second collector to emitter transistor is carrying 1.85 voltage. But for the first transistor, collector to emitter voltage is unknown. Can we apply KVL again? Again travel from top to bottom. If you go like that, it will become as usual minus 10 voltage plus 2 voltage plus collected to emitter voltage drop of the first transistor plus 1.85 voltage plus 1 voltage equal to 0. Shall we start adding? See, 2 plus 1 will become 3. 3 plus 1.85 will become 4.85. So minus 10 plus 4.85 will become 5.15. So I can say the collector to emitter 1 voltage will be equal to 5.15 voltage. Yes or no? If we add this to, again it will become 10 voltage overall. Okay, sir. So we found the operating point of, sorry, yes, of course, it is called collector to emitter voltage of the first transistor. If in the same question, if you are requested to identify the operating point of the transistor 1 and 2, identify the operating points of transistor 1 and transistor 2. How will you do that? So let us assume the top one is transistor 1 and the bottom one is transistor 2. So here, operating point means VCE1, comma, collector current is IC1. Okay, it will be equal to. Similarly here, operating point means VCE2, comma, collector current ICE2. How will you figure it out? Let us see. So collector to emitter voltage already we found. For the first transistor it will be 5.15. For the second transistor it will be 1.85. So this is 5.15 voltage. This is 1.85 voltage. What about the current? So we know current is remains same in both cases. So it will be 1 milliampere only. In both cases, the collector current will be 1 milliampere only, because they told that the value of beta is very large. When beta is very large, then collector current will become approximately equal to emitter current. It means the value of base current is approximately equal to 0. I am telling that base current is not equal to 0. It will never be 0. Only in cutoff region you can find that the value of base current will going to be 0. Here we are not in cutoff region. We are in active region. So base current must be there. But that value is not significant. It will not create any significant effect in the voltage drop. So that's why we are ignoring the effect and we are approximately equating the value of base current equal to 0 in order to simplify the question as simple as possible. So we did everything, and see the value of collector to emitter voltage drop in both the transistor, we can say VCE1 and VCE2 both are greater than the value of VCE SAT. VCE SAT means 0.2 voltage. If you observe, the value of VCE1 is 5.15 and the value of VCE2 is 1.85. Both are greater than VCE SAT. It means it clearly indicates that the transistor is being operated in the active region. Okay. I hope you all understood clearly how to do all type of questions. See, this is how we have to solve. See, we understood everything now. Entire things. Question diagram may be looking like a big one. See, I have been utilized almost 50% of this slide to draw this diagram. When people are looking into this kind of diagram, they are thinking, oh my god, this question will become too difficult. போச்சு இதுக்கு இந்த கொஸ்டினை கண்டிப்பா நம்ம அட்டன் பண்ண முடியாது, நம்ம இவ்வளவு நாள் படிச்சதெல்லாம் வேணும் போச்சு. There will be blah 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 blah. Nothing is there. Simply be patient and look into this circuit, apply all the given data, simply apply KVL, KCL. See, it doesn't matter whether you are in BJT or MOSFET or you are doing DC analysis or AC analysis, it doesn't matter. If you are very strong in circuit theory, analog 99% you can gather, you can gain all the score. Easily you can crack all the question. One or two questions I'm telling now, that will be conceptual. You must know, because here we are designing some devices, they are having certain properties. Some people are operated in the saturation region, some people will be operated in the linear region. They are having their own advantages and disadvantages. So you have to keep some of those things also into mind, such that everything will become easy for you. 100% you can get the mark. Okay, fine. I hope you all understood everything regarding this question. It's time to explore the next one. Let me try to draw the next question. Yes, actually, the reverse saturation current, the given is the reverse saturation current. The reverse saturation current of the collector base junction. The reverse saturation current of the collector base junction. The reverse saturation current of the collector base junction. So in the bracket they told that we know how to write this collector base junction reverse saturation current means ICBO of a BJT of a bipolar junction transistor of a BJT is found to be 10 nanoampere is found to be 10 nanoampere. Yes, sir. Next, at a low collector voltages, they are telling that they found this at a low collector voltages, at a low collector voltages. Of course, they are talking about reverse saturation current. This voltage must be very less. Next, the low voltage current amplification factor. The low voltage current amplification factor. The low voltage current amplification, the low voltage current amplification factor in bracket they told alpha is 0.98. You know the value of alpha is always around 1. It will be always close to 1 only. I told you this beta is always very less. Now the question is find out the change in collector current. Find out the change. Find out the change in change in collector current means IC. I am writing it directly. Find out the change in collector current when its base open. When its base opened. When its base opened. When the collector voltage is increased such that alpha increased by 1%. They are telling that when the base open under collector voltage, 1 minute guys, collector voltage VC is increased and collector voltage VC increased such that alpha increased by 1%. அவ்வளவுதான் இதான் கொஸ்டின் கொடுத்துருக்காங்க. என்ன கேட்டிருக்காங்க find out the change in collector current. collector currentல என்ன சேஞ்ச் வரும் பேஸ் வந்து ஓப்பன்ல வச்சுட்டாங்க ஆல்மோஸ்ட். see open in the sense beta is very large, okay, almost, and they are increasing the collector voltage. collector voltage வந்து increase பண்றாங்க. அப்ப என்ன ஆகுதுன்னா ஆல்பாவோட வேல்யூ வந்து 1% increase ஆகுது. so collector voltage increase பண்றாங்க, ஆல்பாவோட வேல்யூ 1% increase ஆகுதுன்னா what can be the expected change in the value of collector current IC? Now you can read the question once and try to figure out the answer. How to solve this question? Take your time, no issue, but just think about it. What is the best expected way to solve this question? What is the change in the value of collector current? See guys, one more thing I forgot to write here. They have written that collector current is ICEO. That is collector to emitter saturation current, reverse saturation current. Actually, they are talking about find out the change in collector to emitter reverse saturation current only. Forgive me. And here, let me write one more thing. I might have forgot to tell you. See, we know collector current IC can be written as beta into IB, yes sir, plus 1 plus beta times of collector to base reverse saturation current. You all know this expression. Yes. So from here, actually this is the collector current. This current will going to travel from collector to emitter. So this, if this expression, actually this current is going to travel from collector to emitter in the sense, this is identifying this what? Reverse saturation current that is traveling from, if I will talk about only collector to base, then this is the reverse saturation current that is traveling from collector to base. So whereas this overall current, this is also overall reverse saturation current only, but this current is linked with the collector to emitter terminal. I'm repeating one more time. If we are talking about only collector to base, then we are talking about the reverse saturation current that is traveling from collector to base. But after multiplying it by a factor of beta, actually see 1 plus beta means we know this factor will come when we are bringing the relation between emitter terminal also. So what will happen is after multiplying it by the factor of 1 plus beta, this overall current will tell us the collector to emitter saturation current. So this current can be simply considered as the collector to emitter reverse saturation current. In any exam, if the value of collector to emitter reverse saturation current is directly given, then you can also write this collector current IC equal to beta times of I into B plus replace this overall current by ICEO. Okay. See, while solving the problem, if I will introduce these things, you will not forget. If I will simply derive, if I will say this is the relation, just memorize it, keep it in your mind. If I do like that, you people will not observe the significance of these formulas. Right now, you might be understanding this. Just register it into your brain. Anyway, now they are talking about ICEO only. So now you know the relation between ICBO and ICEO. When the value of alpha is changing by 1%, what can be the expected value in the value of, again, ICEO? What can be the expected change in the value of ICEO? That is the actual question. Can you proceed now? Okay, I will do one thing. I will solve this question. Okay, you can try later because see what they have given. Let us collect all the given data. The reverse saturation current of the collector to base ICBO, we know they have given that the value of collector to base reverse saturation current they told that is 10 nanoampere. In the question it is clearly given that that is 10 nanoampere because that is reverse saturation current, it should be 10 nanoampere, very less. And they told that the value of alpha equal to 0.98. Next, they have given the value of alpha also. You all know how to bring beta from here. Sir, why you need beta? Because if we want to know the value of collector to emitter saturation current in case 1 before changing the value of alpha. Anyway, let us complete. What they did is initially according to the given data, this one and this one, we can identify the value of collector to emitter saturation current because we know the relation now. But after that, what they did is they are increasing the value of this current amplification factor by 1%. See that this amplification factor alpha is increased by 1%. When we are increasing it by 1%, what can be the expected change in the value of ICEO? That is the question. So in the case number 1, ICEO 1 can be written as the formula is 1 plus beta times of ICBO 1, case number 1. Anyway, we are going to increase the value of alpha only. We are not going to touch this current. So no need to be bothered about it. Let us keep our attention with the beta and try to figure out the value, percentage change. Right? Okay, sir. How will you figure it out? We know the value of beta can be written as alpha by 1 minus alpha. I'm calling it as alpha 1, I'm calling it as beta 1 because case number 1. Now it is 0.98 upon 1 minus 0.98. Alpha value is given, right? If you put 1 minus 0.98, what you will be getting? It will become 0.02. Yes or no? So 0.02 means 1 by 0.02 will be 50. So 50 into if you multiply it by 0.98, this overall value will become equal to 49. So we found the value of beta 1 equal to 49. If the value of beta 1 is 49, just to substitute this value here, 49 plus 1 will become 50. And ICBO value is already given as 10 nanoampere. So we can easily say that the value of collector to emitter reverse saturation current in case number 1 will be equal to 50 into 10 is what? 500 nanoampere, or we can say 0.5 microampere. Yes, sir. So that is the value of collector to base reverse saturation current. Anyway, you can treat this one. You can treat this one as equation number 1 or data 1, first case. Now, second, what they are going to do is they are going to increase the value of alpha 1%. 1% means what? The value of alpha 1 is given as 0.98. Now tell me what is the alpha 2? Alpha 2 equal to alpha 1 is already existing plus 1% of alpha 1. Yes or no? Is there any mistake in my conclusion? Already existing value is 0.98. Now we are going to increase that value by one more 1%. What is the 1% of alpha 1? Let us see. 0.98 plus 1% means 1 into 0.98 by 100. Yes or no? Yes, sir. So if you divide 0.98 by 100, it will become 0.0098. So 0.98 plus 0.00, sorry, 0.0098. If we add these two value, what will you get? You will get 0.9898. Yes or no? Just we have to add this value with the 0.98. Yes, sir. That is the new value of alpha. Then what is the new value of beta from this? Beta 2 will become alpha 2 upon 1 minus alpha 2 again. So alpha 2 is 0.9898 upon 1 minus 0.9898. So we have to subtract 1 from this. Then we have to take reciprocal for this. Again multiplied by 0.9898. I am getting 97. Approximately I am getting 97. That is the value of beta 2. So if you know the value of beta 2, then what is the new value of collector to emitter saturation current in the case 2? They are simply increasing the value of beta only. So after that I can say it will become 1 plus beta 2 times of, see there is no any changes in the reverse saturation current, that is again fixed. 1 and 2 both are same only. It will be equal to collector to base 1. The only thing is they are changing the value of alpha, because of that beta also getting changed. So it will become 1 plus 97 now into 10 nanoampere. So I can write 98 into 10, it will become 980 nanoampere. That is the case number 2. Now what is the question? The question is percentage change from 1 to 2, right? The question is find out the change in the value of collector current. What is the expected change? Right, so they have option given in percentage, so I'm just going with the percentage. If you observe the options were given in percentage. So how will you identify the percentage change? So the percentage change will be equal to, just identify, keep the magnitude in the options. They just kept the magnitude. See here, what is the new value? 98. What is the old value? Actual value is what? 500 nanoampere. Now what is the new value? So what we have to do? We have to do, the actual value is 500, measured value. Now the new value is 980. So you can do like this, 500 minus 980. I'm just considering the magnitude. divided by 500 in percentage. I have to multiply it by 100. So 980 minus 500 or 500 minus 980 will give you same only because we put mod. I'm just considering the percentage value. So percentage change is what? If you subtract this two, it will become 480. Yes or no? It will become 480. This 20 will get cancelled out. 480 by 5. So we can cancel it. 9 times of 5 will be 45. Yes, remaining 3. So 6 times 96 percentage. So the percentage change is 96 percentage. That's all. So that is how we are solving this question. So here what we learned? We learned one thing that is new. Collector to emitter, reverse saturation current. How to bring the relation between collector to base reverse saturation current and collector to emitter reverse saturation current. I hope now hereafter you won't forget this formula. Just make a hint. It's very important because there are so many questions. So whatever the question that I am trying to push it here, it will be covering some of the new concepts slowly, and after that you'll be able to solve at least 95 percentage of all questions. So don't be bother about it, right? Sure, let us go ahead with the next question. See what it is given is they have given one transistor. Just observe the diagram. Now the resistor is given everywhere, it is connected, and this is NPN transistor only. Here we are going to take one more node, and I am attaching feedback resistor here. Then it is connected with the transistor. That is the given data. And on the top, here we are going to apply 12 voltage supply. So let me register the remaining given data. This is 1 kilo ohm resistor. And here also again 1 kilo ohm resistor. And here also again 10 kilo ohm resistor. You know, this base resistance is always very high. This is again going to be 1 kilo ohm resistor. Everything is given, and they told that the value of alpha is equal to 0.99. We know this value is approximately around to 1 only, and base to emitter voltage is given 0.7 volt. Yes, and circuit is shown in the figure. The value of the collector current will be dash. The question is the value of the collector current IC is dash. You know where we have to consider the collector current. Collector current எந்த இடத்துல வரும் அப்படிங்கிறது நமக்கு தெரியும். I don't think that you people are expecting the answer from my side. Take 2 to 3 minutes. Solve and drop your answer in the comment section. Do it fast. Try it by yourself. Don't expect it from my side. What is the value of collector current? Anyone got the answer? Any idea? Okay, fine. See, I have given sufficient time. I hope you all have tried this question once. Now it's time to explore this, right, in our own way. Let me try to solve this question. As usual, we are always assuming that the transistor is in active region only. That is what our assumption. Yes, sir. Shall we start? Yes, with that hope, we will be trying to solve the question. Let's. What is the question? Collector current is dash. Where is collector first? This is collector current. The current that is flowing through the collector is called the collector current. So I'm calling it as collector current. Actually, it's a beautiful question, I think. So let's see. So to know this collector current, I'm just evaluating the entire parameter of the circuit. What I'm going to do is, we know this is base. So this current is called base current. This current is actually coming from here only. Okay. Now we know this current. If you apply KCL, Kirchhoff current law, I can easily say that the value of emitter current IE equal to collector current IC plus base current IB. Yes, sir. This conclusion is over. Next, what I can say further, this is the one conclusion I got it. Now, how should I explore all the values? Let us see. Alpha is given in the question. Alpha equal to 0.99. Can you calculate the value of beta from here? Why not, sir? The value of beta equal to alpha upon 1 minus alpha. So the value of alpha is 0.99 divided by 1 minus 0.99. What is this? 1 minus 0.99 means 0.01. So 1 by 0.01 will be 100. 100 into 0.99 will become 99. So we found the value of beta equal to 99. Fine, sir. This is fine. Next, if we know the value of beta, then as usual we can apply KVL for the outer loop and the inner loop to figure out the value of these parameters. First, I am trying to apply the KVL for the outer loop. I am just going to travel only with the outer loop. You know, here the current flow through the circuit is called emitter current. So current entering point plus leaving point is minus. And the next, here this 10 kilo ohm resistor, current entering point plus leaving point is minus and entering current is called base current. We know here the emitter current will be flowing. You know the reason. And okay, on the top we can represent the battery like this. Yes, sir. Minus plus 12 voltage. Now if you apply KVL, you will be getting minus 12 voltage plus emitter current IE into the value of resistor is 1 kilo ohm. 1 kilo ohm means what? 1 into 10 power 3 plus next 10 kilo ohm resistor. What is the current flowing through the 10 kilo ohm resistor? Base current. 10 kilo means 10 power 3 plus next one. Again, emitter current IE, same current into resistor is 1 kilo ohm. Sorry, this is 1 kilo ohm. So 1 means 1 into 10 power 3. I hope we have been added all the parameter. It will become 0 now. So here we know how to bring the relation emitter current. See, 1 kilo ohm into emitter, 1 kilo ohm into emitter. It will become 2 into 10 power 3 into IE. And one more thing, emitter current IE can be replaced by 1 plus beta times of IB, base current IB. We know the value of beta, that is 99. So 99 plus 1 will become 100. So it will be 100 times of base current IB, since the value of beta is 99. So the overall value will become 100 times of base current. Here already we can write like this. So minus 12 plus, we have 2 times of emitter current. So 2 into emitter current will be replaced by 100 times of base current IB into there is 1 kilo ohm, that is 1 into 10 power 3. This all will become a single group. Yes. plus we have the base current IB. Here we have only 10 into 10 power 3. Let us try to add all these values equal to 0. Now if you observe, 2 into 100 will become 200. 200 plus we have a 10 here. So 210. 210 into 10 power 3 into base current IB and pass the 12 voltage. I made one more mistake. See, base to emitter voltage I skipped. 0.7 voltage. Just now my mind is going with that. Forgive me. Add plus zero point 0.7 voltage with this expression. That is very important. You can't skip that voltage. Minus 12 plus zero point 0.7 will become minus 11.3. If you pass it to the right side, it will become plus 11.3 voltage. From this, I can say the value of base current finally will be equal to 11.3 upon 210 into 10 power 3. You can pass it to the numerator. It will become 10 power minus 3. Now, 11.3 upon 210 will give you the actual base current. The value of base current will become 0.0538 into 10 power minus 3 ampere. Okay, sir. So we have been explored the value of base current. You can also write it in microampere. 53.8 microampere. That is your wish. Okay, sir. Fine. So from this base current, it is very easy to explore the value of collector current. So we know collector current IC equal to beta times of base current. We know the value of beta, that is 99 into collector current. Just now we found 0.0538 into 10 power minus 3. Yes, sir. Now if I multiply it, so 0.0538 into 99, if you put 5.327, it will become 5.327. 10 power minus 3 means milliampere. Sir, we figure out the value of collector current, sir. Is it your answer? Do you know what happened? They have given four options in the examination for this question. But after finding this answer, I had surprised that this answer is not there. ಅದಕ್ಕೆ ಸರ್ಪ್ರೈಸ್ ಆಗக்கூடாது ಸರ್, ಶಾಕ್ ಆಗೋಣ, right? Yes, I had shocked that this answer is not there in the option. Then what happened? Why this answer is not there in the option, sir? What happened? I don't know, but I have started thinking about it. We got the collector current, that is correct only. We got 5.327 milliampere, 5.327 milliampere, that is correct. After that, I was sitting into this question. This is very first time people started facing this type of question. Prior to that, all the questions simply we are solving, applying KVL, we got the answer. This time also we are applying KVL only, sir, we got the answer. Yes, you are correct. But do you remember, in each and every question, after identifying all the given data, I used to check whether the transistor is an active agent or not. Am I checking or not? Whether they are asking in the question or not, but I am doing. We have been done in all other questions, previous questions. Yes, I have started analyzing in this question also in the same way after that. See, current entering point is plus, leaving point is minus. Can you please let me know what is the voltage drop across this 1 kilo ohm resistor? 5.37 milliampere into 1 kilo ohm will give you 5.327 voltage drop. Now we know collector to emitter voltage can be written as like this, VCE. Yes. Do you know the value of emitter current? I don't know, but we can easily identify. How? 1 plus beta times of base current. Then what this value? Beta is 99. So if I will substitute the value of beta here, it will become 100 times of base current. This is 100. If I multiply it by 100, you will be getting 5.38 milliampere, I can say. So the voltage drop across this 1 kilo ohm resistor here will become 5.38 voltage. How? Kilo and milli will get cancelled. 1 into 5.38 will become 5.38 voltage. Now current entering point is plus, leaving point is minus. In this 1 kilo ohm resistor also same 5.38 voltage will be dropped. Why? Resistor value is 1 kilo ohm. Same emitter current is coming there also. Emitter current is 5.38 milliampere. So the voltage drop will become 5.38 voltage. Now I have started applying KVL to the collector to emitter terminal from top to bottom in this way straight away. Let us estimate the value. Minus 12 voltage plus first 5.3 voltage in the top 1 kilo ohm resistor. Then the voltage drop across the collector resistor. There I found 5.327 voltage. Then collector to emitter voltage. Then bottom we got 5.38 voltage equal to 0. Can you please add 5.38, 5.327 plus 5.38 plus 5.38? Totally I am getting minus 12 plus 16.087 plus collector to emitter voltage equal to 0. Now plus 16.087 minus 12 will become what? If I subtract this two, you will be getting 4.087 voltage. So what I found is 4.087 voltage plus collector to emitter voltage equal to 0. Okay then sir, yes, but we got plus here. From this, if you observe the collector to emitter voltage, I am getting minus 4.087 voltage sir. What was our assumption? We were assumed that the transistor was an active region, and we did all the analysis. Finally we got the answer that the collector current is 5.327 milliampere sir. But when it is not there in the option, then I understood that our transistor is not in active region. Why it is not in active region? Your transistor will be operated in the active region only when the collector to emitter voltage will become greater than the value of collector to emitter saturation voltage. I told you this collector to emitter voltage, saturation voltage is 0.2 plus 0.2 voltage. Now if you observe the collector to emitter voltage that we received here, it is in negative, so it is less than 0.2 voltage. So I told under this situation your transistor will be entering into saturation zone. So our given transistor is not in active region, it is in saturation region. Okay, sir. So when our transistor is in saturation region, you cannot apply that relations like collector current IC equal to beta times of IB. That relations at all directly is not possible. You should not directly write this kind of relations. But only thing what you can do is we identified that the transistor is in saturation region. So when transistor is in saturation region, we know some default values. What default value? The collector to emitter voltage we know. Collector to emitter voltage in saturation region, it is fixed. It will be equal to 0.2 voltage. Yes. So just with this data, take the same question once again from the beginning. Substitute this value between the transistor 0.2 voltage. Again proceed from the beginning. Try to figure out the answer. Do whatever you want, but don't apply this relation. This is wrong in saturation region. If we are in linear region, then only see collector to base both are linear. This current gain is fixed basically. So both are linear in the sense if there is any changes in the base current, then collector also will change. That is called a linear region. But I am saying that the transistor is going to be operated in the saturation region. In saturation region, then how can I apply this relation directly? No sir, that is not possible. So linearly they won't vary. So I cannot apply this relation directly. Then what should I do, sir? What you can do is you have to think, take the same question. Okay. After doing all this analysis, we understood that the transistor is in saturation region. What should I do? Only thing is collector to emitter voltage G is 0.2 voltage. Remove all other parameter. Just to take the given data and again proceed from the beginning. Apply KVL. You can apply KVL on both sides. But only thing is you can't bring the direct relation between collector and base current like IC equal to beta times of IB. That kind of relations you cannot directly write it here. Just apply KVL. Let me give you the clue. Apply KVL input side. Again apply KVL in the output side. Go from this way and another one is straight way. You will get two KVL equation with the two unknown. Just solve the two unknown equation. Two unknown means it will come in terms of base current and collector current, emitter current. So by solving that, now what you can do is replace this emitter current by IC plus IB such that your entire equation both 1 and 2 will be in the form of IC plus IB. Shall I write it? It's better. I can write by myself such that we can avoid the confusion. See, if you apply KVL for this loop, what you'll be getting? 1 kilo ohm resistor, 10 kilo ohm resistor, 1 kilo ohm resistor. So this equation will become minus 12 voltage plus emitter current IE into 1 kilo ohm. 1 kilo means 10 power 3. Then in the base we have 10 kilo ohm resistor. So base current into 10 kilo ohm. 10 into 10 power 3 plus base to emitter. Even in saturation region also, base to emitter means diode will be in forward bias only. We know in saturation region, emitter junction, collector junction both will become forward bias. So undoubtedly you can take the same voltage and you can proceed further. It will become 0.7 voltage plus under 1 kilo ohm resistor. Once again, emitter current IE into 1 kilo means 1 into 10 power 3. Okay, equal to 0. Now see this, I can replace this emitter current IE equal to collector current IC plus IB. Sir, I am telling that don't use this relation. Collector current IC equal to beta times of IB. This is linear operation. Linear operation means we know that region is called active region. Are we in active region now? No. When we are not in active region, then how can you use this relation directly? You should not use. While solving the problem, I am telling. So don't use that relation. Just replace this emitter current by IC plus IB. So here also, anyway, you can add these two first. It will become 2 times of IE. So I can say minus 12 plus 0.7 will give you minus 11.3. Minus 11.3 plus. Now if I will replace, it will become 2 times of emitter current. Emitter current will be replaced by collector current and base current. So IC plus IB into 1 into 10 power 3 as usual. Plus one more base current is there. That is 10 times of IB is there. IB into 10 power 3 equal to 0. Now see there, 2 times of IC we can write. So I can write 2 times of collector current IC into 10 power 3 plus 2 times of IB plus 10 times of IB will become 12 times of IB into 10 power 3 equal to, pass this minus 11.3 to the right side, it will become plus 11.3. Treat this one as your equation number 1. Okay, this is very important. Fine, sir. Now apply the same thing for the second loop. Again 12 voltage, 1 kilo ohm, 1 kilo ohm. Collector to emitter voltage we know, again 1 kilo ohm. So totally we will have 3 1 kilo ohm. If you apply KVL, start from minus 12 voltage plus, once again emitter current IE into 1 kilo ohm means 1 into 10 power 3 I am directly writing, plus we will be having collector current IC 1 into 10 power 3 plus collector to emitter voltage is 0.2 voltage, that is already given, plus again emitter current IE into 1 into 10 power 3 I can write 10 power 3 directly equal to 0. Now here again what we can do is emitter current IE can be replaced by IC plus IB. Fine. So that's all. This thing's over. Now minus 12 plus 0.2. What we can do? Minus 11.8 voltage plus, if I will replace this IC by IB. First of all, this IE will become 2 times of IE. And then you can replace IE by IC plus IB. So 2 times of IC plus IB plus collector current IC into 10 power 3 equal to 0. Now add, see, 2 times of IC, I think I left 10 power 3. 2 times of IC plus IC will become 3 times of IC. Finally, I can write 3 times of IC plus 2 times of IB into 10 power 3. Anyway, both are having 10 power 3, undoubtedly, equal to 11.8 voltage. Treat this one as your equation number 2. Already we have equation number 1. What is equation number 1? 2IC 12IB. So what we are having is 2IC into 10 power 3 plus 12IB into 10 power 3 equal to 11.3, right? That voltage, yes, it is 11.3. This is equation number 1. Now directly we can't subtract these two equations. So I am multiplying it by 2 and this one I am multiplying it by 3 to solve this equation. Whole equation. Both LHS and RHS. such that first one will become, see this one, I am taking this one, 6 times of IC into 10 power 3 plus 4 times of IB into 10 power 3 equal to, it will become, I think 23.6, right? So 11.8 into 2, it will become 23.6. Yes, we are correct. Second, if I multiply it by 3, 6 times of IC into 10 power 3 plus 3 times of 12 will become 36 times of base current IB into 10 power 3 equal to 3 times. Again 33.9, it will become 33.9. Now it's time to solve this. Directly change this sign. Minus, it will be plus, minus, again it will become minus. Such that these people will get cancelled. 4 minus 36 will give you minus 32 times of IB into 10 power 3 equal to 23.6 minus 33.9. If you put that, we will be getting what? Minus 10.3. So minus minus will get cancelled. 10.3 we have to divide it by 32, right? So the value of base current IB finally coming here as, uh, 1 minute, I am getting 0.321 into 10 power minus 3 ampere. So this is the value of base current. Okay, sir. Then how will you get the collector current? Take any one equation. So you can take equation number 2 or equation number 1. It's your wish. And substitute the value of base current. So let me take equation number 2. Sorry, 1. Equation number 1 means this one. Already we decided, no? This one. 2IC 12IB equal to 11.3. See there, I'm getting 2IC plus 12 IB. We know both are multiplied by 10 power 3. That is correct. We know this both will be multiplied by 10 power 3 equal to 11.3, right? Yes, sir. Shall we substitute? Yes. If I substitute that value here, 0.321, 10 power minus 3 into 10 power plus 3 will become 1. So 12 into 0.321, we have to multiply it by 12. It will become, so finally 2IC into 10 power 3 plus 3.8625 equal to 11.3. Let us pass it to the right side and subtract it with 11.3. So finally it will become 2IC into 10 power 3 equal to 7.4375. So the value of collector current IC finally will become, what will become? You have to divide it by 2. So it will become 3.71875. Pass this 10 power 3 to the right hand side. It will become 10 power minus 3, or we can say milliampere. Finally, we got the value of collector current. Yes or no? Yes, sir. So that is how we are solving the question here. See, what is the value of collector current that we got in active region? The value of collector current IC, what we got is 5.327 milliampere. But this is wrong, right? So here the value of collector actual current is what? 3.71875 ampere. IC sat is less than the value of, do you remember? Let me write the second condition. I have also told you the value of collector current is greater than the value of IC sat. What will happen? Then the region of operation transistor, see, IC sat is less than IC. The current is less, saturation region current is less than IC. So then the region of operation is saturation. Do you remember? I told this. Suppose if the value of collector current IC is less than the value of IC sat, that is the current in active region is less than the value of current in saturation region, then the operation will become active region. So while going up with the collector current, we are going with this condition. See that our condition is satisfied. The value of collector current in the saturation region is less than the value of collector current in the active region. Our transistor is in saturation region actually. So we assumed initially our transistor was in active region, so we got this current. But later we understood that our transistor is not in active region because the value of VC sat is went wrong. It became negative. So it should not be possible. So our transistor must be in saturation region. So both conditions are verified. collector to emitter voltage, through that also we verified, and the collector current also we verified. Okay, so this is how we are solving the problem. So always, what is the conclusion? That's why whenever I am solving the problems while calculating the value of collector to emitter voltage or any other DC parameters, it's very important to check the region of operation also, because we don't know in which region our transistor is being in operation. So far, we just kept the assumption that our transistor is in active region, active region, active region, and we got the conclusions also. Suddenly, they kept the twist. Suddenly, they took the question in saturation region, and they haven't given any data about it. So, these kind of questions also will be asked in the examination. So, it is always better to be conscious. Nothing is to bother, but don't forget to apply any conditions that I told you. In saturation region, some things are invalid and you have to apply common sense. Sir, IC equal to beta times of IB is the linear relation. We are in saturation region. How can we apply this? Sir, you should ask this kind of question. So yes, we can't apply directly these things. That's why I have been solved. See that how I have calculated the value of collector current and base current just by forming the equation and solving them. I did not applied any relation that after finding the base current, did I put IC equal to beta times of IB? No, I did not put. We should not do that. We should go with the actual equation. So in saturation region, don't apply that relation. This is how you have to solve the equations. But anyway, as usual, it is KVL only. You will not going to apply anything beyond this. Fine. So, whatever the things that we have discussed in the today class, I hope you all have understood everything in a proper way. Try to solve and gather as many questions as possible.